Hello guys, I'm Gautham Thejur back here today with another big, it's not big, but it's a wonderful, and if you learn it, you'll be so, I was so amused. That's it. It's called as Gauss's Theorem. Do you know what's a Gauss's Theorem? Gauss's Theorem means it's a law, which means that the electric flux linked with a closed surface is equal to 1 by epsilon naught. Epsilon naught means permittivity in free space or whatever it is. We can take epsilon naught in wherever cases, and if it's a case of water or anything. 1 by epsilon naught times the total charge enclosed in the system. Let me give an example. Let's take this. Consider this as a closed surface, closed rectangular box, and this has some charge bodies in it. Okay, and the electric flux, which means the electric field in a certain area, it is called as the electric flux. Okay, don't forget that electric field in a certain given area is called as the electric flux, and the electric flux of this enclosed surface is equal to 1 by epsilon naught or epsilon 0 times the total charge enclosed in this system. That's it. Let me tell you once again. The electric flux linked with a closed surface is equal to 1 by epsilon naught times the total charge enclosed in the system. Epsilon naught means a permittivity in free space. I'm telling you it once again. Okay, that's it. Gotcha? Let's now go for the Gauss's theorem's proof. Consider this as a closed surface, closed circle, and this has a point charge Q at its center, and the circle's radius are, you can take this as R or this as R. One R is only needed. Radius, that's it. This is the radius of the circle or height or whatever it is. Radius R. Then telling about the electric field intensity. When a point charge Q is situated with the distance R, which is the radius, the total charge at the electric field intensity will be radially outwards. Okay, that's it. E equals, this charge is going outwards, that is said as so, because a point charge Q at its center with the radius, which has a radius, the circle has a radius, and the electric field intensity will be radially outwards. The electric field intensity equals, the equation is 1 by 4 pi epsilon naught. 4 pi means the 360 degree of the circle. 4 pi epsilon naught into Q by R square. This is the second radius, so it is taken as R square. 1 by epsilon naught into Q by R square. E equals, let's consider this equation, epsilon naught into Q by R square. I forgot to tell you something, that we are taking a definite areas. It can be this area or wherever it is. We are taking a particular area's electric flux, right? Have you recognized it? That's it. Okay, the particular area's electric flux is mentioned here. So electric field intensity will be radially outwards, and this area, because it's a sphere, it is similar to that of the electric field intensity. Because it's a sphere, this area will be radially, which means the same as the same angle, cos 0 degree, when considering about both of these. Now let's take this equation as 1. And do you know the electric flux equation? Another equation, phi equals, phi means the electric flux, phi equals vector E, which means it has a direction, right? Vector E, the electric field intensity has a direction. Dot, which means the dot product or multiply, into ds, which also has a direction. This is the direction, which means the ds is the electric flux, certain areas electric flux which has a direction, so ds. this equation 2. Got it? And now let's apply this E in here. So phi equals, we need to find the electric flux, right? So we are going to apply this here, 4 pi epsilon naught into Q by R square into ds. We're taking one more thing here because it's a cos 0 degree, right? Which means that when we consider about the circle, it's cos 0 degree. But when the shape changes, we having another angles, right? This is a Gaussian surface. So cos 0 degree. Now find a space here. Probably I should write here. Phi equals 1 by 4 pi epsilon naught into Q by R square into ds into cos 0 degree. It's probably 1 into 1. Okay, and now phi equals this ds, which means the electric flux is area, right? This area is a circle, so we are going to write the area of the circle here as 4 pi r square. But when this changes to a triangle or rectangle or wherever, but it should be, the one condition is necessary, that is it should be a closed surface, enclosed surface. So because it's a sphere, we are going to take the, in place of ds as q by r square into ds as 4 pi r square. Gotcha? And this r squared cancels off, that you can see there. 4 and 4 cancels off, pi and pi cancels off. And that's it. You're left with a thing that is called as phi equals q by epsilon naught. And this is the electric flux's equation conveyed by Gauss. Can't you see this? It's so amazing, right? Phi equals q by epsilon naught, which means the permittivity in free space. 1 by epsilon naught is the only permittivity in free space out of the total charge there. And that's the electric flux there. Got it? Let me tell you once again. The electric flux linked with a closed surface, consider this as a closed surface. The electric flux linked with this enclosed surface is equal to 1 by epsilon naught times. That is here 1 by epsilon naught. We can write it as q into 1 by epsilon naught, right? 1 by epsilon naught times the total charge enclosed in this system. And that's it. I hope you enjoyed or understand what I told here. Signing off from Gautham Thejur. If you like this video, don't forget to leave a thumbs up there. And for more updates, you can subscribe if you need it out.